In this video, we will learn about C arrays, specifically single-dimensional arrays. We will cover how to declare and work with these arrays. Let us begin. Let's understand how to declare arrays in the C programming language. There are multiple ways to declare an array. The first way is declaration with size. This involves specifying the data type of the array, followed by the array name, and the size of the array enclosed in square brackets. For example, int numbers open square bracket 5 close square bracket declares an integer array named numbers that can hold 5 integer values. The second way is declaration with initialization. In this method, you declare the array and also assign initial values to its elements within curly braces. For example, int numbers open square bracket 5 close square bracket is equal to open curly brace 10, 20, 30, 40, 50 close curly brace. The third way is size inference from initialization. Here you don't explicitly specify the size of the array. Instead, the compiler infers the size based on the number of elements provided during initialization. For example, int numbers open and close square bracket is equal to open curly brace 10, 20, 30, 40, 50 close curly brace. Now let's discuss memory allocation. Arrays are stored in contiguous memory locations, meaning each element is placed next to the other in memory. Each element occupies the same amount of memory, which depends on the data type of the array. In the case of an integer array, each element typically occupies 4 bytes. So, if the array starts at memory address 0x1000, then the first element numbers open square bracket 0 close square bracket is stored at 0x1000. The next element numbers open square bracket 1 close square bracket is stored at 0x1004 and so on. Thus arrays are stored in contiguous memory locations. Each element occupies the same amount of memory, which is 4 bytes for an integer. Let us learn how to access array elements. To access individual elements of an array, you use the array name followed by the index of the element in square brackets. Remember that array indices in C start at 0, not 1. The last element of an array of size n is at index n-1. For example, consider the array int numbers open square bracket 5 close square bracket is equal to open curly brace 10, 20, 30, 40, 50 close curly brace. To access the first element, you would use numbers open square bracket 0 close square bracket, which gives you the value 10. Similarly, to access the third element, you would use numbers open square bracket 2 close square bracket, which gives you the value 30. You can also modify array elements by assigning a new value to a specific index. For example, numbers open square bracket 1 close square bracket is equal to 25 changes the value at index 1 from 20 to 25. And numbers open square bracket 4 close square bracket is equal to 99 changes the value at index 4 from 50 to 99. To visualize this, consider an array with elements 10, 25, 30, 40, and 99. Accessing the element at index 1, numbers open square bracket 1 close square bracket, gives you 25. Accessing the element at index 4, numbers open square bracket 4 close square bracket, gives you 99. Let's explore how to iterate through arrays using loops. Iteration involves accessing each element of the array sequentially. A common way to do this in C is by using a for loop. Here's an example. Int numbers open square bracket 5 close square bracket is equal to open curly brace 10, 20, 30, 40, 50 close curly brace. Int I. For I is equal to 0, I less than 5, I plus plus. Printf open parenthesis quotation mark element percentile d colon space percentile d backslash n quotation mark, comma I comma numbers open square bracket, I close square bracket close parenthesis. In this example, the for loop starts with I is equal to 0 and continues as long as I is less than 5. In each iteration, the value of I is increment by 1. Inside the loop, printf is used to display the element at index I. The loop counter I is used as the array index to access each element sequentially. You can also perform operations on the array elements during iteration, such as summing all the elements. For example, int sum is equal to 0. For I is equal to 0, I less than 5, I plus plus. Sum plus is equal to numbers open square bracket, I close square bracket. In this case, the sum variable accumulates the value of each element in the array. To visualize the iteration process, consider the array with elements 10, 20, 30, 40, and 50. In the first step, I is equal to 0, and you access numbers open square bracket 0 close square bracket, which is 10. In the second step, I is equal to 1, and you access numbers open square bracket 1 close square bracket, which is 20. In the third step, I is equal to 2, and you access numbers open square bracket 2 close square bracket, which is 30. This process continues until you have accessed all the elements in the array. Thus, the loop counter I is used as the array index to access each element sequentially. Let's explore common array operations. Arrays are often used for various manipulations such as finding the maximum or minimum value, copying elements, and reversing the array. Here are some examples. To find the maximum value in an array, you can initialize a variable max with the first element of the array. Then, iterate through the rest of the elements and update max whenever you find a larger value. For example, int max is equal to numbers open square bracket 0 close square bracket. For I is equal to 1, I less than 5, I plus plus. If numbers open square bracket I close square bracket greater than max, max is equal to numbers open square bracket I close square bracket. To copy array elements, you can create a new array, and then iterate through the original array, assigning each element to the corresponding index in the new array. For example, int copy open square bracket 5 close square bracket. For I is equal to 0, I less than 5, I plus plus. Copy open square bracket I close square bracket is equal to numbers open square bracket I close square bracket. To reverse an array, you can iterate through the first half of the array, and swap each element with the corresponding element from the end of the array. For example, for I is equal to 0, I less than 5 by 2, I plus plus. Int temp is equal to numbers open square bracket I close square bracket. Numbers open square bracket I close square bracket is equal to numbers open square bracket 4 minus I close square bracket. Numbers open square bracket 4 minus I close square bracket is equal to temp. Some common array operations include finding the minimum and maximum values, reversing arrays, and calculating the sum and average. To find the minimum or maximum value, initialize with the first element and then compare with each element. To reverse an array, swap elements from both ends moving towards the center. To calculate the sum or average, iterate through all elements, adding each value to a sum variable, and divide by count for average. Let's discuss common pitfalls and best practices when working with arrays. Some common pitfalls include array index out of bounds. Accessing elements outside the array size causes undefined behavior, as C does not perform bounds checking. Uninitialized arrays. Array elements contain garbage values if not explicitly initialized. Off by 1 errors. Forgetting that array indices start at 0, or looping one element too many or too few. Forgetting array size. C doesn't track array sizes. You must manage size information yourself. Let us understand it using an example. Int ARR open square bracket 5 close square bracket is equal to open curly brace 10, 20, 30, 40, 50 close curly brace. Int value is equal to ARR open square bracket 5 close square bracket. This is an error because valid indices are 0 to 4. Here's a correct example of safe array access. Int size is equal to 5. For I is equal to 0, I less than size I plus plus, printf open parenthesis quotation mark percentile d space quotation mark, comma ARR open square bracket I close square bracket close parenthesis. Another correct way is to define the size as a constant. Hash define size 5. Int ARR open square bracket size close square bracket. Best practices include using symbolic constants for array sizes, always initializing arrays before use, checking array bounds before accessing elements, and using size of array divided by size of array open square bracket 0 close square bracket to get the array length. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.